What if I told you Delta could fly you to Europe in a narrow-body jet? And it might be better than a Boeing 767. What Delta is planning with the Airbus A321XLR is going to completely rewrite how we think about international travel. And the leaked route network I've uncovered is going to shock you. We're talking about direct flights from cities that have never had international service, routes that bypass traditional hubs entirely, and a business model that could force every other airline to completely rethink their transatlantic strategy. Let me tell you about the regulatory battle Delta fought behind the scenes to make this possible, because without understanding that story, you won't appreciate just how revolutionary this aircraft really is. Let's start with what we're actually dealing with here. The Airbus A321XLR, officially the A321-200. Extended long range isn't just a stretched A320 with bigger fuel tanks. This is Airbus's answer to a fundamental question that's been haunting the airline industry. How do you profitably connect smaller markets without flying half-empty wide-body aircraft? The XLR designation stands for exactly what you think: extended long range. We're talking about an aircraft that can fly up to 4,700 nautical miles, or roughly 8,700 kilometers, while carrying a full passenger load. To put that in perspective, that's enough range to fly from New York to Dublin, from Los Angeles to London, or from Miami to Madrid, all in a single-aisle aircraft. If you want to stay ahead of the curve on airline strategy and route planning that affects where you can fly and how much you'll pay, smash that subscribe button and hit the notification bell. Because what we're about to dive into isn't just about one aircraft, it's about the future of how airlines connect the world. But range is just part of the equation. The A321XLR carries between 180 and 220 passengers, depending on configuration, burns about 30% less fuel per passenger than comparable wide-body aircraft. And here's the kicker: it can operate profitably on routes with passenger loads that would make a 767 or A330 lose money. This matters because most transatlantic routes don't actually need 250 to 300 passenger aircraft. They need something right in that sweet spot of 180 to 220 seats that can fly far enough to cross oceans but small enough to fill consistently. Delta currently operates a mixed transatlantic fleet of Boeing 767s, Airbus A330s, and some Boeing 757s on shorter European routes. But here's the problem: the 767s are getting old. The A337s are often too big for thinner routes, and the 757s don't have the range for most European destinations. The A321XLR solves all of these problems in one aircraft. But getting regulatory approval to fly a single-aisle aircraft on long overwater routes required Delta to navigate one of the most complex certification processes in aviation history. Here's something most passengers never think about. When you fly over the Atlantic Ocean, you're potentially hours away from the nearest airport. If something goes wrong with a twin-engine aircraft, the FAA wants to make absolutely sure that plane can reach a suitable airport on one engine. This is called ETOPS, Extended Twin Operations, and it's one of the most stringent certification processes in aviation. For the A321XLR to fly transatlantic routes, it needed ETOPS 180 certification, meaning it has to be capable of flying for 180 minutes on a single engine to reach a diversion airport. But the A321XLR presented unique challenges. Unlike traditional wide-body aircraft, narrow-body jets weren't originally designed for these kinds of extended overwater operations. Airbus had to prove that every system, from engines to avionics to emergency equipment, could handle scenarios that most A321s would never encounter. What most people don't realize is that Delta played a crucial role in the A321XLR's certification process. As the launch customer for the aircraft in North America, Delta's technical teams worked directly with Airbus and the FAA to define operational procedures, maintenance requirements, and crew training protocols. This wasn't just paperwork. Delta had to develop entirely new standard operating procedures for long-haul operations in a narrow-body aircraft. Everything from passenger service protocols to crew rest requirements had to be reimagined for flights that could last up to 8 hours in an aircraft originally designed for 2 to 4 hour flights. The certification process took nearly 3 years, but in early 2024, the A321 XLR finally received ETOPS 180 approval. This opened the door for Delta to begin planning routes that would have been impossible just a few years ago, and that brings us to the part that's going to change everything: the route network Delta has been quietly planning. Here's what I've uncovered about Delta's A321 XLR plans, and some of this is going to blow your mind. We're not talking about traditional hub-to-hub routes. Delta is planning to connect secondary U.S. cities directly to Europe in ways that have never been possible before. First up, Raleigh-Durham to London Heathrow. This route makes perfect sense when you understand Delta's strategy. Raleigh is a major tech hub with significant business travel demand to Europe, but passengers currently have to connect through Atlanta, New York, or Boston. The A321 XLR changes that completely. Internal Delta analysis shows that over 200,000 passengers per year travel from the Research Triangle area to European destinations, and most of them are currently connecting through other hubs. A direct Raleigh-London flight could capture a significant portion of that traffic while also attracting passengers from surrounding markets like Norfolk, Greensboro, and even Charlotte. Next, Boston to Shannon, Ireland. This might seem like an odd choice, but it's actually brilliant. Shannon is Delta's gateway to Irish and secondary UK markets, and Boston has the largest Irish-American population outside of Ireland itself. Plus, Shannon offers pre-clearance for U.S. Customs, meaning passengers can clear immigration and customs before departing for onward connections. What Delta is really doing here is creating a hybrid network model. Instead of forcing all European traffic through their traditional hubs in Atlanta, New York, and Detroit, they're selectively adding point-to-point routes that bypass hubs entirely. This strategy works because the A321 XLR's economics allow profitable operation at lower passenger volumes. A route that might need 200+ passengers per flight to be profitable with a 767 might only need 140 to 160 passengers with an A321 XLR. But Raleigh and Boston are just the beginning. Industry sources suggest Delta is evaluating direct A321 XLR service from cities like Nashville to Amsterdam, Austin to London, Tampa to Dublin, and even Portland, Oregon to Reykjavik, with connections to European destinations. Here's where this gets really interesting. American and United are scrambling to respond to Delta's strategy, but they're facing a problem that could give Delta a multi-year head start in these markets. Delta was smart enough to get in line early for A321 XLR deliveries. Their first aircraft are scheduled to arrive in late 2024 and early 2025, while American and United won't see their first XLRs until 2026 or later. In the airline business, a 2-year head start on a new market can be decisive. But launching new routes is just part of Delta's strategy. The real revolution is in how the A321 XLR changes the fundamental economics of transatlantic flying. Let's address the elephant in the cabin. Can a narrow-body aircraft really provide an acceptable experience for 7 to 8 hour flights? Delta's answer is a resounding yes, but it required completely rethinking how you configure a single-aisle aircraft. Delta's A321 XLR will feature a 3-class configuration that's unlike anything they've done before in a narrow-body. We're talking about 20 business-class seats in a 1-to-1 configuration. Yes, you read that right. Single seats on one side of the aisle, plus 28 premium economy seats and 132 economy seats. The business class product is where Delta really went all out. These aren't just angled flat seats, they are fully lie flat beds with direct aisle access for every passenger. The seats are based on the same platform Delta uses on their wide-body aircraft, just adapted for the narrower cabin. Premium economy gets significant upgrades too. 38 inches of pitch, wider seats than standard economy, and enhanced meal service that's designed to compete with European carriers' business class offerings on shorter routes. But comfort is just part of the equation. Delta's A321 XLR comes with the latest generation of in-flight entertainment systems, high-speed Wi-Fi that's comparable to what you'd get at home, and power outlets at every seat, including economy. The aircraft also features additional lavatories compared to standard A321s, larger galleys for meal service, and crew rest areas that meet international long-haul requirements. Because remember, these are 8-hour flights with international crew duty time regulations. All of these cabin improvements sound expensive, and they are. But the reason Delta believes this will be better than flying wide-body aircraft isn't just about passenger comfort. It's about operational flexibility and route economics that change everything. Here's where the A321 XLR becomes a genuine game changer for Delta's network strategy. On a per-passenger basis, the XLR burns about 30% less fuel than a Boeing 767 and nearly 40% less than an Airbus A330 on comparable routes. In an industry where fuel represents 25 to 35% of operating costs, that's not just an improvement, it's a fundamental advantage. But the real magic happens when you look at break-even economics. A typical Delta Transatlantic route with a 767 might need a 75 to 80% load factor to be profitable. The same route with an A321 XLR might be profitable at 65 to 70% load factor, which opens up route opportunities that were previously unviable. This is crucial for the secondary market routes Delta is planning. A route like Raleigh to London might only support 4 to 5 flights per week with seasonal variations. With a 767, that kind of frequency and seasonal demand would make the route marginal at best. With an A321 XLR, it becomes solidly profitable. The A321 XLR also provides operational flexibility that wide-body aircraft simply can't match. Because it's based on the A321 platform, Delta can easily redeploy these aircraft to domestic routes during slower international periods, use them for charter operations, or even swap them between different international routes based on seasonal demand. Maintenance costs are significantly lower too. The A321 XLR shares parts, systems, and maintenance procedures with Delta's existing A321 fleet, which means lower inventory costs, easier crew scheduling, and more efficient maintenance operations. Plus, the A321 XLR can operate from airports that can't handle wide-body aircraft, either due to runway length, gate compatibility, or infrastructure limitations. This opens up route possibilities that were previously impossible regardless of demand. But all of these operational advantages mean nothing if Delta can't execute the strategy effectively, and the competitive response from American and United is already creating challenges Delta didn't anticipate. American Airlines and United didn't sit quietly while Delta developed their A321 XLR strategy. Both carriers have placed substantial orders for the aircraft, but they're taking different approaches to deployment. American Airlines has ordered 50 A321 XLRs, with plans to use them primarily for transatlantic routes from their Charlotte and Philadelphia hubs. But here's the interesting part. American's strategy focuses more on traditional hub-to-hub routes rather than the point-to-point approach Delta is taking. This creates a fascinating competitive dynamic. American is using the A321 XLR to strengthen their existing hub operations by adding frequency and improving economics on existing routes. Delta is using it to create entirely new markets and bypass hub constraints. United's approach is somewhere in between. They've ordered 50 A321 XLRs, but are planning a mix of hub strengthening and new point-to-point routes. United's advantage is their strong West Coast presence, which opens up Pacific routes that Delta's East Coast focus can't easily match. But the real competitive threat might not come from other U.S. carriers. It could come from European airlines that use the A321 XLR to attack U.S. markets directly. JetBlue is already doing this with their A321 XLR orders, planning direct service from secondary U.S. cities to London and other European destinations. Their low-cost model combined with the A321 XLR's economics could undercut Delta's pricing on overlapping routes. More concerning for Delta, European carriers like Iberia and TAP Air Portugal are evaluating A321 XLR service to secondary U.S. markets, potentially beating Delta to routes they've been planning. This competitive pressure is forcing Delta to accelerate their deployment timeline, but that creates its own challenges in terms of crew training, route planning, and market development. Launching long-haul A321 XLR service isn't just about buying aircraft. It requires significant changes to airport infrastructure and operations. Delta has been working with airports on both sides of the Atlantic to ensure they can handle the unique requirements of long-haul narrow-body service. At Raleigh-Durham, Delta is investing in gate modifications that can handle international arrivals and departures, including customs and immigration facilities that weren't previously needed for Delta's domestic operations there. This isn't cheap. We're talking about millions of dollars in infrastructure investment for each new international gateway. Crew scheduling presents another challenge. Long-haul A321XLR flights require different crew qualifications, duty time management, and layover planning than traditional domestic narrow-body operations. Delta has had to develop entirely new crew bases and training programs to support these operations. Ground handling is more complex too. International flights require different catering, cleaning, fueling, and baggage handling procedures. At secondary airports that haven't handled international service, Delta has had to work with ground handling companies to develop new capabilities and train staff. Flying international routes also means navigating complex regulatory environments that vary by destination. Delta's A321 XLR routes require new bilateral aviation agreements, landing rights negotiations, and regulatory approvals in each destination country. Security requirements are different too. Passengers on international flights face different screening procedures, documentation requirements, and arrival processes. Airports handling new international service need to upgrade their security and customs facilities accordingly. All of these operational challenges are solvable, but they're expensive and time-consuming. The airlines that can execute most efficiently will have significant competitive advantages in the A321 XLR era. The A321 XLR represents more than just a new aircraft type. It's the beginning of a fundamental shift in how airlines think about international networks. The hub-and-spoke model that has dominated aviation for decades is being challenged by point-to-point economics that weren't possible before. Industry analysts project that the A321 XLR and similar aircraft could support direct international service from 50 to 100 secondary U.S. cities that have never had it before. We're talking about cities like Richmond, Virginia flying direct to Amsterdam, or Albuquerque, New Mexico, with direct service to London. Consumer research consistently shows that passengers prefer nonstop flights, even if they cost slightly more than connecting flights. The A321 XLR enables airlines to offer nonstop service on routes where it was previously impossible, potentially capturing premium pricing for what was previously connecting traffic. The success of the A321 XLR could have significant implications for the wide-body aircraft market. Routes that currently require 767s, A330s, or even 777s might be better served by larger numbers of smaller aircraft with higher frequency. Higher frequency service is almost always preferable to passengers than larger aircraft with lower frequency. If the A321XLR can make twice daily service profitable on routes that currently only support daily wide-body service, passengers win, and airlines can capture more business travel demand. This trend could reshape aircraft manufacturing too. If airlines shift toward long-range narrow bodies for medium-density international routes, demand for traditional wide-body aircraft could decline significantly. Boeing and Airbus are both developing new aircraft types to compete in this evolving market. From an environmental perspective, the A321 XLR's superior fuel efficiency per passenger could reduce aviation's carbon footprint, especially on medium-haul international routes. The aircraft produces approximately 20% lower emissions per passenger than comparable wide-body operations. The A321 XLR is also certified for sustainable aviation fuel operations, and its newer engines are more compatible with emerging SAF blends than older aircraft types. As SAF availability increases, operators of newer aircraft like the A321 XLR will have environmental advantages. All of these industry implications point to a fundamental transformation in how international aviation works. But the timeline and success of this transformation depends on execution by airlines like Delta. Delta's A321 XLR strategy represents one of the most significant shifts in U.S. airline network planning in decades. By combining advanced aircraft technology with innovative route planning, Delta is creating international flight options that simply didn't exist before. The ability to connect secondary cities directly to international destinations changes the fundamental value proposition of air travel. Business travelers in markets like Raleigh, Nashville, or Austin no longer need to plan extra connection time through major hubs. Leisure travelers gain access to international destinations without the complexity and expense of connecting flights. But success isn't guaranteed. Delta's execution needs to be flawless. From crew training to passenger experience to operational reliability, the competitive response from other carriers could undermine route economics if too many airlines chase the same market simultaneously. Perhaps most importantly, the A321 XLR represents just the beginning of long-range narrow-body evolution. Boeing is developing competing aircraft types, and next-generation engines and materials will enable even longer range and better economics. For passengers, Delta's A321 XLR strategy promises more flight options, potentially lower fares through increased competition, and the convenience of nonstop service from cities that never had international flights before. If Delta executes successfully, this could be a genuine win-win for airlines and travelers. The next few years will determine whether this strategy transforms international aviation or becomes a cautionary tale about overreach. If this deep dive into Delta's A321 XLR strategy got you thinking about the future of aviation, definitely hit that subscribe button and ring the notification bell. We're constantly analyzing airline strategies, route developments, and aircraft innovations that affect how and where you can fly. I'm really curious about your thoughts on this. Have you ever flown transatlantic in a narrow-body aircraft? How was the experience compared to wide-body flights? Drop a comment and let me know. And here's a specific question. Which new Delta A321 XLR route do you think they should launch next? I'm genuinely interested in your predictions and preferences. If you've ever flown Delta internationally, or if you're excited about the possibility of direct international flights from smaller cities, give this video a thumbs up. Your engagement helps us understand what aviation topics matter most to our community. If you want more fascinating facts about aviation, click on the next video right here for another deep dive into the world of aircraft and aerospace technology. Thanks for watching. If you enjoyed this breakdown, hit that like button, subscribe for more aviation content, and don't forget to ring the notification bell so you never miss our latest videos.